There's no doubt that history is about to be rewritten with recent successful alignment of NASA's James Webb Telescope. One of the most expensive and ambitious scientific projects ever attempted, the James Webb Telescope has been successfully deployed in its unique orbit. Its powerful instruments will be able to collect data on a number of things, such as life on other planets and the presence of black holes in the universe. Watch the video till the end as we tell you all the details about the James Webb Telescope. But before we do, make sure to like this video and subscribe to our channel so that you don't miss out on any of the amazing content we have in store for you. The James Webb Space Telescope is an infrared space observatory launched on December 25, 2021 by NASA in collaboration with the European Space Agency, the Canadian Space Agency, along with nearly 300 institutions, organizations, and enterprises from 29 states and 14 countries. The $10 billion Space Observatory is the largest and most powerful space research telescope ever. Hubble Telescope's successor, the Webb Telescope, will explore the cosmos to learn about the universe's history, from the Big Bang to the birth of alien planets and beyond. The JWST is named after James Webb, the former NASA chief. Webb served as NASA's chief from 1961 to 1968, resigning 2 months before the first man walked on the moon. Although Webb's term as NASA administrator is most known for the Apollo moon program, he's also regarded as a space research pioneer. Despite the political turbulence of the moment, Webb outlined NASA's science goals, arguing that deploying a huge space telescope should be a top priority. Under Webb's leadership, NASA launched more than 75 space science missions. The James Webb Space Telescope took 30 days to travel over 1 million miles to reach its permanent home, a Lagrange point, which is a gravitationally stable place in space. The observatory was recorded soaring away from the Ariane 5 rocket that launched it into space in a stunning video. After departing from Earth on December 25, 2021, the James Webb Space Telescope's huge sunshield was successfully unfurled on December 31, 2021. Then, on January 3, 2022, tensioning of the sunshield's 5 layers began and was finished the next day, which was followed by the successful deployment of telescope's secondary mirror. The telescope arrived at L2, the second Sun-Earth Lagrange point, on January 24, 2022. L2 is a location in space that is opposite to the Sun. This orbit will keep the telescope in alignment with Earth as it orbits the Sun. Apart from the James Webb Space Telescope, several other space telescopes have used this place, including the Herschel Space Telescope and the Planck Space Observatory. On February 11th, NASA announced that the James Webb Space Telescope had taken its first photos of starlight. Webb's first photograph was of a star known as HD 84406. Webb's 18 mirror segments on the primary mirror collected light from HD 84406, resulting in a mosaic of 18 scattered brilliant spots. NASA published a revised and enhanced image of HD 84406 on February 18, putting 18 unfocused duplicates of a star into a purposeful hexagonal arrangement. It was decided that the picture stacking process will commence once the observatory has correctly aligned the different parts of the primary mirror. The James Webb Space Telescope arrived at its target over 1 million miles away from Earth, about 4 times farther away than the Moon. Thanks to a successful and precise launch, NASA said that the James Webb Space Telescope could have enough fuel to more than quadruple its minimum mission life expectancy of 10 years. The largest and most complicated space telescope ever built spent much of January 2022 unfolding its mirrors and components in order to come into position to show us the early universe. The telescope is anticipated to revolutionize astronomy as we know it, and the anticipation is great. The Webb Telescope has been anticipated by a whole generation of astronomers. Some believe it has the potential to open up entirely new scientific domains. After unfolding its mirrors, the James Webb Space Telescope performed science and calibration tests, including instrument turn-on and telescope alignment. With little window during its setting, we have already received a number of amazing photographs from the James Webb Space Telescope. According to the Space Telescope Science Institute, the telescope will start to show images roughly 6 months after launch. NASA recently released some photos from the James Webb Space Telescope as part of its ongoing testing of its sensors ahead of science missions. The test photos from the James Webb Space Telescope is already revolutionizing the way we perceive the cosmos. Webb's whole field of view is displayed when the telescope is aligned with all of its instruments. The test photographs from a properly positioned telescope have provided stunning images. It also demonstrates what people from different countries and continents can do when a bold scientific vision to explore the universe is shared. NASA reported on April 28, 2022 that the James Webb Space Telescope had completed its alignment phase after demonstrating that all 4 of its scientific instruments can acquire crisp, well-focused images. With many equipment, NASA's James Webb Space Telescope can now record crisp photos of cosmic objects. After this, the James Webb Space Telescope then started the next and final round of preparations, known as Science Instrument Commissioning. This critical task of commissioning all of the scientific instruments aboard the James Webb Space Telescope began with every instrument on the observatory being used as a sophisticated pair of detectors with custom lenses, filters, masks, and other equipment to enable the instrument achieve its mission goals. By integrating and reconfiguring them for all primary responsibilities, their suitability for real-world science missions will be proven. Furthermore, an itinerary of several locations of the sky to which Webb will be pointed is one of the remaining tasks in calibrating the complete telescope. These patches of sky will alter the quantity of solar energy hitting the James Webb Telescope, allowing scientists on the ground to fine-tune the observatory's thermal stability while it switches targets. After the accomplishment of this step, trained professionals entered the Space Telescope Science Institute's Mission Operations Center in Baltimore. It's worth mentioning that the optical performance of the telescope continues to exceed the engineering team's expectations, with mirrors now pouring cosmic light into a narrowly focused beam of light into each of the instruments. All devices receive diffraction limited image quality, which means that the fineness of the detail visible is as excellent as physically possible given the telescope's size. The James Webb Space Telescope also took an impressive selfie inside the NIRCam device using a dedicated camera. The camera is intended for engineering and alignment applications. The selfie from NIRCam displays the 18 segments of the James Webb Space Telescope's primary mirror. One of the mirror segments shines brighter than the rest in the selfie because it's the only segment that was successfully aligned and gazing toward a star at the time. The James Webb Space Telescope will do much more than just taking photos. One example is helping scientists to know more about the pillars of creation in the Eagle Nebula. They are some of the most well-known areas where stars are born. Stars form in gas clouds, and as they increase in size, the radiation pressure they exert sweeps away the cocooning gas, which could be reused for future stars if it's not too widely scattered. However, seeing inside the gas is challenging. The infrared eyes of the James Webb Space Telescope will be able to see sources of heat, such as stars, forming in these cocoons. Moreover, a number of exoplanets have been discovered in large numbers during the last decade, especially with NASA's planet-hunting Kepler Space Telescope. The James Webb Space Telescope's strong sensors will be able to look at these planets in greater detail, including imaging their atmospheres in some cases. Understanding planet atmospheres and creation conditions should help scientists better forecast whether or not a planet is livable. Just like its predecessor, the Hubble Space Telescope, the powerful James Webb Space Telescope, is projected to take spectacular photographs of cosmic objects that are even further away from our previous range. Fortunately for astronomers, the Hubble Space Telescope is still operational, and it's likely that the two telescopes will collaborate throughout James Webb Space Telescope's early years. The JWST will also thoroughly investigate exoplanets discovered by the Kepler Space Telescope and real-time observations from ground-based space observatories. That's it for today's video. We hope you enjoyed the content of this video. If you did, show some love and hit that like button, and don't forget to subscribe to our channel so that you never miss out on our amazing and informative videos in the future.